Hello everyone. So we have got the idea about the concept of divisibility, and we saw that how we have to find whether a number is to be divisible by 2 or 3 or 5 or 7 or 11, 13, like that. So basically we have to in first hand we have to check the divisibility against the prime numbers, and I hope that you have the idea about the prime numbers. So the thing is that we know that the prime numbers are those numbers. So based on that, you have the concept of prime factorization. So coming to the concept of the prime factorization. So suppose we have to see that whether the any number, suppose say 544. So we, by looking at this number, we can know that it is divisible by 2, also by 4, also by 8, because these numbers. But so after 8, even it is divisible by 16 also and 32 also, but anyway we can understand that that can be. So 8, again further 68 comes, so 68 means 4 into 17, so it means it will be 2 raised to the power 5 into 17. So we know that that way you go for prime factorization. Now the term coming prime, so you know that what is the meaning of prime. Prime means number has only two factors, one and itself. So like 2, 3, 5, 7, 11, 13, all these are the prime numbers. 2 is the only even number which is a prime number, and 3 is the only number which is a multiple. I mean, which is you can say that all other numbers which you will be getting after 3, they will not be multiple of 3. So basically only 3 itself, then 6 is not, or 9 is not, 9 also being, or maybe 15 is not, or even 21 is not. So although they are odd number, but they are not prime. 3 is only here which is considered to be prime. After that, all these numbers, they are in general way they are expressed in the form of 6 and plus minus 1. So all the prime numbers are in that form. Certainly in plus, sometimes minus 1 as well as plus 1 are prime, but as you progress, then everywhere you will not see that. Like suppose you keep 1, so it will be 5 and 7. If you keep n equal to 2, it will be 11 and 13, both are prime. If you keep 3, it will be 17 and 19. If you keep 4, it will be 23 and 25. So 25 is not prime. So like that, all the numbers will be either of this form or so. Now the thing is that when we study tables, so basically when we go for prime factorization, normally if you know the tables of these prime numbers, that is the most important thing. Because once you know the multiplication with 2, then further you multiply, it will be factor of 4, further you multiply with 2, it will be of 8, further you multiply with 2, it will be of 16, like that. So 2 and 3 has to be multiplied, and it is most convenient to multiply any number with either 2 or 3, even with 5 also, because you have to simply do the half of the number and place a 0. So that way you can multiply any number with 5, so that becomes easier. And then and also I have told you that how to define the divisibility using the remainder theorem. So if there is a larger number, and if you need to check that whether it is to be divisible by 7 or not. So if the number, suppose say, is a, b, c, d, e, f, g, h, so we know that a being the remainder a itself, with b 10, with 10. So suppose you do it by 7. So we have done it in our earlier lecture, that plus 3b plus 2c minus d minus 3e minus 2f plus g plus 3h, like that it will go. So basically what you do is if you have 6 digits, so you get a minus d plus 3 into b minus e plus 2 into c minus f. So if you do that, you can find whether this number is divisible by 7 or not. So similarly, by 11 we got like a minus b plus c minus d plus e minus f. How this came? See, a is okay, a is the remainder itself. If you go to b, so 10 was the number, 10 is the remainder, so plus 10b or minus b will be same, so minus b. Then with after 10 it is 100, with 100 a1 is the remainder, so plus c. Then again minus d plus e, so that will go. So that's how it is. Suppose we do go for by 13, so what you do is a is fine. Then if you go to b, you have 10 as the remainder, so 10b. Then you go to c, 100 is the one and 9 is the remainder, so 9c. Then you go to next, so it will be 90 means there will be 12d, but 12d is written as minus d, and similarly 9c will be written as minus 4c, and 10b may be written as minus 3b. So your expression becomes a minus 3b minus 4c minus d. So if any number is there and you have to see that it is divisible by 13 or not, you can just go and do this number. So suppose you have a number like 1, 2, 4, 8, whether it is divisible by 13 or not. So see, you can do like 8 minus 3 into b, that is 12, minus 4 into c, that is 8, and then you have to do it as minus 1. So you will have minus 4 minus 8 minus 1, that is minus 13, and it is divisible by 13. It means this number will be divisible by 13. It is divisible. So you can use all these concepts for all type of numbers, like say suppose you are doing for 17, so you can further see that a, then plus 10b, then you go for 100, it will be 15, so it will be 15c. Then for 150, for that it will be 14d, then it will be 4e, then it will be 6f, and then it will be 9g, and then it will be 5h, and then comes plus 16i. Now you see here that after you count the number of the 1, 2, 3, 4, 5, 6, 7, 8. Now in 17 you have to go up to 8, you have to do. Now this can be further written as a minus 7b minus 2c minus 3d plus 4e plus 6 f plus 9g or like that 9g plus 5h. So this way you can go and you can check whether the number is divisible by 17 or not. Now once you know these whether this number is divisible by that or not, you can go for the prime factorization easily. So what you will do in that case, so suppose you take any number, like say you are taking a number of 5, 2, 4, and you take say 4. So now you see in this number, this is divisible by 4, but before that there is an odd even number, so it will not be divisible by 8. So it is divisible by 4, let it be 4. So it then comes 1311. Now 1311, if you look at, this is divisible by 3. So 1311 will be 3 into 437. Now you have to check this 437 will be divisible by what? Now if you know the table of these numbers, then you can check whether 437 is divisible by any number or not. Now another concept is that 437, if you have to check whether it is divisible by what prime number, so you have to go and see the prime numbers up to its squares. So its square will be less than 21 and it is more than 20. So you have to go the prime numbers up to 21. That is, you leave 2, 3 and 5, it is not. So you have to check with 7, 11 and 13 and 17 and also 19. Now you check with these 5 numbers whether it is divisible or not. With 7 it is not. So you can say 7 plus 9 plus 2 into 4, so it is not divisible by 7. Go by 11. By 11, 7 plus 4 minus 3, it is not divisible by 11. By 13 also you can use the formula a plus 10b plus so a plus 10b plus 9c, so 7 plus 10b 30, 37 plus 9c 14. So again that is not divisible by 13. By 17 also it will be not. By 19, if you see, if you check by 19, the formula is a plus 10b and then by 19 if you go plus 5c, that is the used formula. So a 7 plus 10b, so that is plus 30, 37 plus 5 into 4 20, that is 57. It comes 57 is divisible by 19. It means this number is divisible by 19. So it will be 19 multiplied by 23. So you can write in further, you will have that 2 into 2 into 19 multiplied by 23. So this way you are going to have the prime factorization of these numbers and you can check. Otherwise it will be somewhat cumbersome. If you see these numbers, you will be not be able to come quickly. Certainly you have to check, that with all these kind of prime numbers. So you do the practice with larger and larger numbers and just concentrate on the use of prime numbers. So even you are using the tables, try to use the tables of prime numbers, and that will be helping you the most, once you go to find the prime factorization. So what I suggest you that you must know the tables of all these prime numbers, and also know the tricks of having the divisibility by these prime numbers, especially like when you go after 13, 17, then we have 19, then 23, then 29, then 31, 37, 41, 43, 47, like that. So you can have the formula, and if you will go to more and more classes, then you can have your own formulas for finding these things. So that will make you feel more confident while going for prime factorization, and also study about the numbers. Thank you very much.